Okay, so dear, what did you understand from me so far?
We're talking about the max size and how
Okay.
you can.
Okay, I'm listening to you.
But what's the point of max size? Like, since you don't know what's inside, is that why you do this?
Yes, I have to. So in the normal stacks, we do not know, we don't keep track of the maximum size. We do not know if the stack is full or not because it is dynamic, it will grow in size. But since we are dealing with a static stack is different, totally different from a dynamic stack. And a dynamic stack, we don't know how is it implemented inside. We just only know that we can use push, pop is empty. But in the static stack, then we have to build our methods to actually protect from having an error. What is an error? We cannot insert beyond the limit of the stack. So a static stack is like a cup of water. Once it is full, you cannot insert inside it anymore. But you need your measures. You need to have a measures to be able to prevent yourself from inserting something that is beyond your cup of water. You cannot keep inserting if you reach that level. You need a mark to mark where are you. Did you insert water here? Is that the water level? What is the current water level? You use high. The high variable keep track of where is the water level inside your cup. So your cup is exactly like the static array. It have a limited size. Inside it, previously, if we talk about this dynamic stack, you don't have to worry about that. Okay, is that clear to you?
Okay, do you set the max size or does it find it then?
We set it ourselves based on how many elements we put inside the array. So if I put 0, 0, 0 like that, so and I say my array, my static array is like that. So what is the maximum size in this case? 3. 1, 2, 3.
Yes.
Am I right? So if you put one more, you can say it is 4. This is your maximum size. You cannot put more than 4 elements. Am I correct or wrong? So the maximum size is a variable. You can use, I mean, if the word maximum size is confusing you, so we can use the word size like that. If I say size equal 4, is that fine to you? Is it more clearer to you? This is at the end, this is a variable name. I can use any variable name. It's up to me or up to you. Is that clear to you or confusing still?
Okay, but then why do you subtract it by
1.
1?
That is a very good question because we always subtract the length of the array by 1.
This is like n minus 1.
Excellent. Yes, yes. So if I want to have a pointer, if I want to have a pointer that points here like that to point to the last element in my array, so it will be always pointing to something minus 1. So here I point like that, and then I say this is 0, 1, 2, 3. 3 is less than the size of the array, so it is maximum size of array minus 1. So if I say here is 4 elements, so the last position I have here, which is the highest possible possibility of high, it is actually 4 minus 1. Is that clear? Okay, so that's why if your high equal maximum sign of -1, it means that you return 1. Why? What does it mean when you return 1? That it is full. Your stack is full when you return. So if it is not equal, you return 0. So it means that your stack is able to have something more. So the trick here is that high is your indicator. Is that your cup of water is full already, or I can put more water inside? So if you didn't reach the highest level, you can put more water inside, and nothing wrong will happen. If we put more water on a full cup, the water will flow outside. Am I right? So the same exactly will happen. The again, sorry.
No, I was just saying okay.
Okay, that's good. So we know that how is full is implemented. So we are able to do this check. So is full. Once we call is full, it will get us 1 or 0. Okay, so let us have a look here. So before we push a single value inside, we need to make sure that we don't overflow. Okay, we don't want to push something over the limit. So if is full equal 1, it means that stack is full. We need to print out stack is full. And then we don't do anything else. We exit. So what if it is equal 0? So it means that this part will be executed. So what we are doing here? So I will increment high by 1. Okay. And I will insert something inside the array. Why? What is this thing? This is the input that I am passing here. So when you push, you say push like that. So this is push like that, and I am passing an input, and the input here is 9. So I want to insert 9 in the array or in the stack. Okay, so I want to check what is my high now. Can you look here? What is the current value of high?
-1.
-1. So when the stack is empty, we are having a value of -1. Okay, so we are not even pointing to 0. Okay, fine. So at -1, there is no element, there is no index at -1. Our first index is 0. Okay, am I fine? Is that fine to you? So that's why we are telling that we are pointing to -1, which means that we are pointing to something that is not inside our array or our static array. So this is high at the moment. So it is pointing here. Once before we start to insert, I cannot say s array -1. I cannot say this. This is not acceptable. I need to start from 0. So that's why I add 1. Okay. So if you add 1 to -1, what will happen? It is equal what? -1 plus 1.
0.
0, exactly. So before I insert something inside the array, I increment that by 1. So here I become having 0. So I will insert at the first element position here in the static array. Here I will insert here. So that is actually what push is doing. So it is taking, this is push. So you see here, I increment high by 1, and then once high becomes 0, for the first time I insert, so it will become 0 here, and insert whatever I want to push inside that position, which is position 0. So imagine that I am calling, you see here, I am calling what? What is the first push I'm trying to push here? You see here, 1. I push 1. So yes, it means that now I am pushing 1 inside the position 0. So instead of having 0 here, like that, I will push 1. So I will start to have 1 here. And my high will be now pointing to 0. So this is the marker that I mark my cup is full or not full. Clear so far or difficult?
Okay.
Acceptable?
Yes.
70% understood or less? Less.
Yes, around percent, I think.
Okay. Do you want me to stop and talk about something else? Are you getting saturated?
No, I think it's okay.
Okay, but I mean, I develop a sense that I am able by voice to check if my students are saturated or not, and you are approaching the saturation. I'm afraid of that, but okay. So, do you drive? Do you drive a car or bicycle?
I've cycled, yes.
You cycle, yes. Okay. Are you living in a field or beside a field? So it means that you're there is maybe greenery areas beside you or mountains beside you.
Yes, there's a forest near me.
Okay. Is it common to live beside the forest? Is it safe?
Yeah, sort of.
There is animals that can come out from the forest?
Just like deers and foxes, nothing.
Interesting. Okay. So in Malaysia also many of the new construction that is happening, they cut the forest and then they build houses. So monkeys is very common. So we can sometimes and many times find monkeys coming near our houses. And sometimes also big reptiles can come nearby. Not crocodiles, but and also not a komodo. I think komodo is just popular in Indonesia. We have a very less size. It's just maybe the size of a full hand, your full arm, just a full arm. So we find that in the drains normally. Did you ever see that before near your area?
No, no, just house lizards.
Okay, just house. That is the common one everywhere. Okay, okay. So let us resume. Okay.
Okay.
So now let us discuss about the pop. Do you know the pop do what? Can you read that here from the text?
Yes, it removes the top element from the stack.
Okay, that's good. And so, but before we remove anything from the stack, we cannot remove when the stack is empty. If you want to remove something when the stack is empty, it doesn't make sense. So you need to make sure that your stack is not empty first. So that's why you check here, is empty. Is empty is what? In the normal dynamic, the implementation of the method that's called is empty, we don't care about it. It's not our business. They give it to us ready and we use it. And the same with the pop function. But here we are implementing a static stack. So we need to really look what is full is doing and what is empty is doing. So have a look here. When high equal -1, it means that I have an empty stack. The first initial condition, as you can see here, I start running by having high -1. It means my stack is totally empty. I haven't inserted a single element inside my stack. If I inserted a single element, high will become 0. Is that clear?
Yes.
Okay, so have a look again as is empty. So is empty, return two things, either 1 or -1. If it is full, or if it is empty, it will return 1. If it is not empty, it will return 0. So if you have an empty stack, can you pop something out? Can you remove something out from an empty stack? If you have a cup of water that is empty of water, are you able to get water out of it?
Sorry, no.
No, right? So you are not able to get water out of an empty cup of water, right?
Yes.
Okay, so the same here. Before we try to get anything out of an empty cup, we need to check confirm first. If it is empty, if the empty returns 1, like that, so we say the stack is empty. We cannot pop up anything. So what if it is not? So what are we going to do? So, okay, if it is not empty, this means that we can get something out. But we get something out based on how the stack works. The stack always work in this way. So we push things like that, and we also take things out this way. So consider my stack having a small stack, in this case, 1, 5, and 10, and my high is pointing here. So if I say pop, I use the high, and high is already 0, 1, 2. So my high will be pointing to the position 2. So it will be 2 will be stored inside high variable. So when you try to get something from the array at position 2, so you say here S array 2, because he's saying high here like that. So you're trying to get the 10, and then you store the 10 inside an element variable. And then after you do that, you subtract high minus 1. Any idea why on earth we need to subtract minus 1? We didn't do that in arrays before, but why here we need to do subtract minus 1? Why do you think so?
Is it because we subtracted the array length as well?
Okay, do you remember when we pop something out of a stack, we say we make like that. We used to make this way. Let me put another. So we used to say like that. When we pop something from the array, it means that it is deleted forever. It is lost. What does it mean it is lost? That we cannot access it again. So, and the one that controls what you can access or what you cannot access is your high. So if you subtract your high minus 1, so it will become pointing to 5, and it will never point to 10 again. So the next time we try to pop something out of the stack, we actually will pop out 5 instead of 10. So in the stack, in the normal dynamic stack, you keep popping up until the stack is empty. So every time you pop up something, it is deleted from inside the stack itself. So we need to simulate that behavior using this code. So this code is saying, get me out what the pointer is pointing to. The pointer is pointing to the end or the top of the stack, which is 10 here at the moment. So once we get 10 out, we store it somehow. We need to subtract high, not to point to 10 anymore, because we already get it out. I mean, is that clear to you, or I need to remind you again? I think, you tell me.
Could you explain it again?
Okay, yeah, I can. Stacks. Okay, let me get that. We go back to the basic. This is the basic of the dynamic stack that we are trying to simulate. You see here, do you see here what is happening? You always deal from one place, one side of the stack. The stack of books. Do you remember the stack of the books? If you keep putting books on top of your desk on top of each other, are you able to get that before you get out the books on top? Cannot, right? So if this is your biology book and you put it on top, so the first book that you're going to take out, which is pop, you use pop to take out that book out. So you take it out, and then you're able to see another books under it. And then next you can take that book out. Next you can take that book out. But before you remove your biology book, you cannot remove anything in here. The one that is marking the top of your stack is called top here in this condition. Okay, so in the dynamic stack, we never needed to care about where is the top element in my stack. I never need to care that because it was done automatically for me. But since we are dealing with a static structure here, so we have to care about the top of the stack. So can you see here? This is how we push. So if my stack have only one and I push, so I push 2 here, then I see my stack is having like that. So I only push. I don't increment anything. I don't do anything other than pushing. I just keep calling push. And then once I call push with 5, it become already inserted like that. Is that clear so far?
Yes.
Okay. And then if I want to pop, what will happen? So keep removing, right? So once I pop, you see, I take 6 out. So now I see here no 6. I take 5 out. This was 5. I take it out. So it's removed. So my step keep becoming empty until I have only one element in my stack. Like that. It's only one now in my stack. Am I right? Can you see that?
Yes.
Okay. So this is a normal stack. And if you keep removing and adding, who's taking care of how many elements remaining, or if it is full or empty? Actually, the computer was doing that for you. Okay, the internal computer was doing that for you. It was doing a good job taking care of the stack. But in our case, we are trying to use the array to implement the stack. So we have to take care of many things. We have to take care of is full. We have to mark the top of the stack with a marker, and we need to increment that. So if I am here having high pointing to 6, once I remove up 6 with pop, I need my marker to point to 5. I cannot leave it pointing to 6 anymore. I already remove it. So every time you remove something, you need your high to go down. So once a high going down, it means that the high need to be subtracted by 1 every time, because we only pop one item at a time, right? So it means that I need to subtract high minus 1 at a time. So every time I remove something, I subtract. Every time I remove something, I subtract high. So high will be always pointing to the top of my stack. I remove the top of my stack, I need to subtract it to point to the next item. Is that clear? Or still difficult?
No, it's sort of clear.
Really? Okay, that's good. That's good. Okay, I'm so sorry. Let me see here. Again, this code will not be fixed in your brain until you write it. I need you to write that code on your own after that. So again, when we pop an element, we say the current element, we store it in an element variable like that. and then we subtract the high, which is marking the top area of the top of my stack, like that. So instead of pointing here, it will point to the next element in the stack, and then I return element. So whatever I popped up, I need to return it. Okay? Is that clear so far? Hello,
Okay.
hello. Okay. So let me, I understand that you start to become saturated. Let me show you an exam question. What kind of questions that come for this kind of thing here? Okay. No, 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 not this one. Where you'll be static stack, yeah. No, I think I missed something here. Is that? Let me see here. Yeah, it is this one. Yeah. So, okay, this is the kind of question that you will see in your exam about that topic. So you see here, he say, this is in 2019 exam question. So explain the use of one-dimensional array as a static stack. Your answer should include brief outlines of the push and pop operations and tests for empty and full stacks. So this is the kind of question that you will see here. When you're going to be asked about static stack. So I would go through this very fast. Can you see here? I starting from 0. This is an array elements of array A of n elements. So here the last element is n minus 1, the size minus 1. Okay? Hello, hello.
Yes.
Hello, hello.
Yes.
Yes. Okay. So we need to keep track of the top of the stack. So we need to use something called top variable. Okay. So we can use high, we can use top. It is the variable name is up to us. We can choose whatever we want to use. So in the standard answer, he say we can use top. Okay. You need to explain what is the push. So you need to increase the top by 1, and then so once you start top by minus 1, so you need to increase by minus 1 by 1. So increase top by 1 and then insert. So that is exactly what I explained to you. And then they explain also about pop. So he said here, you need to return the element a top and decrease top by 1. This is how we subtracted high minus 1, if you can remember. Is empty, check if the stack is empty. So I will pass you that, and I will try to go through a new topic very fast so that we are not in a bad position tomorrow, because we still have many topics to cover. So can I do that, please?
Yes.
Okay, so I will choose something that is not so complicated. We have something called trees. Do you remember anything about trees? Do you remember what is a tree?
No.
So, okay. Okay. Trees, typically, it is a way to search for elements. They use trees to search for elements. And trees have many traversal methods. So we are able to loop through a tree using different methods, 3 methods actually. So we will write here no code. This is pure theoretical questions that might come here. So this is, we call that the root element. So, and everything to the left of the root, so bigger elements. So if you have 1 and then 2 and then 3 and then 4 and maybe 6 like that. So the first element, if so, they will give you numbers and they will ask you to arrange that in a tree like that. So the first number that you get, you put it as a root. So, and then you check 2 is bigger than 1 or smaller than 1. Okay. And then based on that, you start to put here 2 if it is bigger or smaller than 1. So again, big numbers will be inserted here and small numbers will be inserted here. So if you look at 2, it have also 2 branches. So we have 4 here and we have here 5. Okay. So, and let me see here. So we also have this 3 and 6 in this way. Let me explain and go directly to the traversal method in this case, and we go through more details of explaining how to convert numbers into trees like that tomorrow when we have time. I worry we only have 7 minutes remaining. So I would like to tell you, if you have a tree like that, consider you have a tree that is built like that. Okay. So when they say I want to have in the exam a pre-order traversal like that. So what is a pre-order traversal? So I would get the root first, and this is left, and this is right. So I will get the root. So I will take 1 and then list it here. Okay. And then I will take the left, which is 2, and then 4, and then 5. And then I go up, take 3 and 6. So how this work? I said we get the root, and then we go down to the left, we take 2. Okay. After we get 2, we go to the, we keep moving to the left, and we take 4, 5, and then we go down like that. So you need to memorize how that works. You get root first, after this left branch, and then right branch. So the answer for a question that asks you about pre-order traversal is they give you a tree like that, and they ask you to list how the numbers is traversed. So we take with the root here 2, and then we move to 4 and 5, and then we move from 5 to the right branch. We take 3 and 6. So do you see it like that? Hello,
Okay.
hello. Okay. So okay. Let me show you what is the other 2 before we go from here. So okay, the first order, it take, this need memorization, I believe. So you need to take the left,
Yeah.
and then the right, and then the root. So you see the difference between this and the second one. So the left means that you need to start with 4. You start with 4, and then 5, and then you go up. You take 2, and then you go down from 2 to 6, and then you go up, take 3, and then you go up to the root 1. So left, right, root. So we start with the last leaf that we have, 4. So from 4 we move to 5, and then we go up. We take 2, and then we go to the leaf of the most the last one, the last leaf on the right side. We take 6, and then we take 3, and then we take the root. This is the root. This is 3 when we're going up, and this is 6 here. So this is right, and this is root. Can you tell me what did you understand from here so far? Or you didn't understand anything?
It's a little hard to understand, but this is all theory based.
Yes, unfortunately, this is theory based, that you have to memorize it, how it works. You just need to know that post order, you start with left, right, and root, and you have to train yourself to see. You go to the lowest leaf first, and then take the one at the same level, 5, and then you start to go up. Okay? And then go down to the rightmost leaf, 6, and then you start to go up until you reach the root. Okay? Let me pass you the next one, and then if you revise that today, and then we talk about it more tomorrow, then I believe it will be not bad. So have a look here. This is called in order traversal. We say we start with left, root, right. So left, we start with D here, like that. Never mind. Let me share with you. This is a summary. This is a summary that carry all the 3 in order, pre-order, and the post order. So the last one we was talking about, it is in order. Okay, so the in order is here. So we start with left, and then root, and then right. Left, root, and then right. So can you please tell me what you see here? Where is 4?
4 is towards the left.
So this is 4, right?
Yes.
So after 4, 2, Amber, can you hear me?
Yes.
So after 2, we go down to take 5. Okay?
Yes.
And then after that, we immediately go to the root. So this is 1 referring to the root. Okay? And then we go again to the lowest leaf. So this is a leaf. So we take 6, and then 3, and then 7. So do you see a pattern here? 4, 2, 5, root. 6, 3, 7, finish. So this is 6, 3, 7. This is the leaf. Okay, and the middle is the root. Tomorrow we talk again about that. I will try my best to pass you the slides. Typically, it takes 36 hours to prepare the slides, but for your case, I try my best. Okay.
Yes,
thanks a lot for your patience, and try a bit again tonight to revise the slides, please, that I gave to you. Okay.
Yeah.
Okay. All the best for you. Take care.
Thank you.
Thank you.
Bye.
Thanks. Bye-bye.